Number 3, we've got this integral to evaluate, and when I look at this I see some things that will factor, so that would be my first idea, is try to factor. So this is going to be 2 to e. This factors as the difference of squares, x minus 1 times x plus 1. The denominator, you can factor out an x, and I can get the x minus 1s to cancel, so I've got 2 to e x plus 1 over x. That's not in our list, but I can split that up. 2 to e x over x plus 1 over x, and that's 2 to e 1 plus 1 over x. And so I get x plus natural log absolute value of x. Turns out we don't really need absolute value in this case because these numbers are positive, but I'll put it in there until I get my limits in. Anyway, plugging in the e, I get e plus natural log e, dropping the absolute value because e is positive, minus 2 plus natural log 2, again dropping the absolute value. And there's really not much else to do here. Natural log of e I do know is 1, so I get e. This would be plus 1 minus 2. Well, I'll do that. Plus 1 minus 2 minus natural log 2. That is, this is going to be e minus 1 minus natural log 2. So that's what you get for that integral. This one is pretty clearly, we use the fact that we have powers of tangents and secants, and I've got an odd power on that tangent, and so we remember that what I'm supposed to do in that case is save a tangent but also save a secant. So I'm going to save a secant and a tangent, and that leaves me with a tangent to the 4th, which I'm going to write as tangent squared, and I still have a secant squared. And I'll change this tangent squared to secants. This is secant tangent, which we recognize as the derivative secant. That's why I'm changing everything to secants. This is secant squared minus 1 squared, secant squared. So just changing that tangent squared to secant squared minus 1. And now I'm ready to do my substitution of u equals secant, and du is secant tangent dx, which is exactly what I need it to be. So turning all those secants into u's and getting rid of the secant tangent dx, I get u squared minus 1 squared times u squared. That's a squared there. And du. Multiplying this stuff out, this is u to the 4th minus 2u squared plus 1, and then I'm going to distribute the u squared. So this is going to be the integral of u to the 5th minus 2u to the 4th plus u squared. And now I can integrate. I get u to the 6th over 6 minus 2u to the 5th over 5 plus u cubed over 3. And putting the secant back in, it's secant to the 6th over 6 minus 2 secant to the 5th over 5, and secant cubed over 3. So there's my integral of that one.